So let's take a look at these energy levels and understand the orbitals that we find electrons in. Okay, so we had our Bohr model. So remember, our Bohr model was this planetary model. Okay, so that was our Bohr or our planetary model. It's nice, it lets us visualize those discrete energy levels, but in reality, while we have the discrete energy levels, we're not traveling around the nucleus in an orbit like this. So we have to talk about Schrodinger for a second. So Schrodinger started to propose this quantum mechanical model of the atom. Okay. Schrodinger's equation is incredibly complicated. There's a ton of different solutions for it. I don't know if any of you have taken calculus, but solving the Schrodinger equation requires triple integrals and all sorts of crazy stuff. So we get a wave function and we get a probability function. So we get these orbitals and we get a probability of finding an electron at any given position. So we can't know everything about an electron. I can either know where the electron is or like what its vector is. I can't know both at the same time. So I can get a probability function. I can get an idea of about where I might find an electron. Okay. So when I look at the Bohr model versus this quantum model, our Bohr model, again, it's really nice. Okay, we can look at those orbitals, helps us visualize that. But the quantum mechanical model, in actuality, what's happening is we get this probability density mapping. So the more dots is a higher probability of finding an electron in that spot. Fewer dots, less probability of finding an electron in that particular spot. So you can see here with this picture that probability density closer to the center, I have a higher probability of finding an electron. So what we figured out is that we have 4 different types of electron orbitals. We have s orbitals, p orbitals, d orbitals, and f orbitals. The sp, d, and f, or sp and d orbitals are easy to describe the shapes of. We have one s orbital, it's spherical in shape. We have 3 p orbitals, they look like dumbbells. We have 5 d orbitals, and they end up looking like 4 of them look like 4-leaf clovers, and the last one looks like a dumbbell with a donut. We have 7 different f orbitals, and these are really complex in shape, and I'll show you what they look like in a little bit. Okay. So our s orbitals, again, super nice and easy. I can draw an s orbital. Oh, look. There's my s orbital. So you can see picture A here. This is that probability density mapping showing that, in that denser region where there's more dots, that's where I have a higher probability of finding an electron. Okay. Now, if I go from energy level 1 to energy level 2, what happens to the size of the s orbital? It gets bigger because I get further out from the nucleus. Okay. All right, so that gets bigger because we get further out from the nucleus. Okay. And so you can see going from energy level 1 to energy level 2 to energy level 3, we get bigger and bigger as we go further out. Okay. Now our p orbitals, okay, again, these look like dumbbells. We've got these 3 different spatial orientations to describe our 3 different p orbitals. So we can identify, we've got a px, a py, and a pz. Sometimes you'll see those identified. It's not always necessary. I've got 1, 2, 3 p orbitals. And so when we start putting electrons in places, we don't always put in the px, the py, the pz. This just gives you that idea to help you remember that each one of these 3 different p orbitals is oriented in a different direction. One, in this case, one's along the x-axis, one's along the y, and one's along the z. Okay. All right, our d orbitals, again, so we've got these 5 different orbitals, and we get these different spatial orientations. So again, we have 4 of them, look like 4-leaf clovers, and then the last one we call a dumbbell with a donut, or actually, I've actually had some students call it a double-ended pacifier. So whatever description like helps you remember it. Again, we can also put some designations on these guys so that we remember that, again, they are lying in different places along the plane. And then there's our F orbitals. There's 7 different ones. These guys are crazy. I'm not even going to attempt to draw one, but these are very complex shapes. Okay. So now, when we have our different energy levels, okay, so when I'm at energy level 1, the only orbital that appears for me is an s orbital, okay, and that's going to lie in period 1. Now, when I go down to period 2, if you count across period 2, you're going to count 8 elements. That's because in period 2, now I have our s orbital, and my 2 p orbitals show up, and so now I can have these 3 different p orbitals. Energy level 3, when I get down to period 3, now I have s orbitals, p orbitals, and d orbitals available to me. And when I get to energy level 4, now, which starts at period 4 on the periodic table, now I have s orbitals, p orbitals, d orbitals, and f orbitals available to us. Now, the energy of these is really interesting. Okay? If you notice, we're going to go from 1s to 2s. That makes sense. 2s to 2p. Okay? 2p to 3s. All right, so now we're building that up. 3s to 3p. 3p to 4s. And then what's interesting is the 3d orbitals are actually lower in energy than the 4p. So period 3 on the periodic table. We don't actually fill any d orbitals. We don't start filling d orbitals until we hit the transition elements, and those don't show up until period 4. But the electrons in those d orbitals are actually in 3d orbitals. So we go from 4s to 3d, and then we go from 3d to 4p, 4p to 5s, and then 5s to 4d. Okay? And so here's kind of a bigger picture of that. So we'll fill 1s, 2s, 2p, 3s, 3p, 4s, then 3d, then 4p. Okay? For this particular course, I'm not going to get into the f orbitals. We aren't going to fill anything from the lanthanides and the actinides. That's where the f electrons start to get filled, is in the lanthanides and the actinides that are at the bottom of the periodic table. We're not filling f orbitals in this course. Okay? And so these are our different orbitals. And again, remember our s orbitals, we can draw a sphere. Our p orbitals, we can get that dumbbell. Our d orbitals, we can do these guys. And then our f orbitals are just crazy, and I'm not even going to try to draw those. So those are our different orbitals.